Okay, hello, welcome back. Sorry, I was having some technical difficulties over there, and our previous person had to go. Thank you for bearing with me whilst I got that all fixed up. In the background over here, we have Loki having a delightful nap. He's getting all rested up for all the geography that we're going to learn about. Okay, so let's get this started again. Great. Okay, so that all seems to be working again. Yay! Lovely. So I was just talking about what mid-latitude cyclones are and how they are formed. So let's move on a little bit. There we go. Wait, I think I went through all of this stuff already. I think I may have used the notes that covers everything. Let me just double check. Oh, yes, I did. Okay, fine. That was everything on mid-latitude cyclones. Okay, so then let's take a look at the different type of cyclone. So let's go to tropical cyclones. Okay, let's go with factors necessary for formation. That's probably a good start. So how tropical cyclones are formed. So a tropical cyclone we also refer to as a hurricane or a typhoon or something of the sorts. There we go. Factors necessary for formation of a tropical cyclone. So there are three main key ingredients. You have to have all three of these factors before you see a tropical cyclone forming. The one is you need to have hot, humid air. The other is you have to have a very low pressure system. And then finally, we need Coriolis force. Coriolis force is what makes everything go round and round. Okay, so let's see if we can find all three of these criterias on null school and possibly find a tropical cyclone that's currently happening. Okay, now I know that we have specific conditions that we need to meet. So tropical cyclones tend to form over the ITCZ, that is the Intertropical Convergence Zone. So that is where you have all of the warm air converging together. It is warm because it's by the tropics. And since it's converging, it rises, so it creates a low pressure system. So it already meets two of the criterias. The ocean temperatures need to be about 28 degrees Celsius, so it needs to be very warm, very humid. And that's why we usually find them quite late in summer or very early autumn. So the reason why is because then it's had time to warm up the ocean throughout summer. And by the time early autumn hits, it's still quite warm from summer. So let's see what we can find. So this was our mid-latitude cyclone. We don't need that anymore. And I'm going to switch to ocean. There we go. Great. So now it's telling us all about the ocean. And I want to see, so this is the one that I'm choosing, sea surface temperature, SST. So remember, we need warm ocean temperatures. What are you doing? What are you doing? There we go. Now it's working. Okay, so we need warm conditions in the ocean, and you can kind of see where it's red or minimize. There you go. where it's red or this burgundy deep color, that is where it's the warmest. So if I click on over there, you can see the temperature at the bottom. No, I'm not Australian, I'm South African. I never understand how people get those accents confused. Maybe I've just lived in South Africa for too long. But welcome to GeoCafé. Nice to have another member. If you look at the bottom over here, you can see the temperature, 29.8 degrees Celsius. So it's warm. I'd call it warm. Okay, so everything around here, that is meeting our criteria. Now, step number 2. We need rising air. Oh, okay, so we have the hot air, obviously. Oh, wow, that's cool. No, I'm a high school geography teacher. So I'm just helping the geography students who are writing their exams tomorrow. So that's what this is supposed to be, a last minute crash course before their paper. So then none of this will be new to you. You'll be familiar with all of this. Okay, we've got that. We've got the diagram, which we'll get back to. No, I'm streaming on YouTube as well. So they can also join on YouTube. Okay, then we need a intense low pressure. So I can't really see pressure on null score. It doesn't really do the labeling, but we can figure it out using the wind. So where you have, there we go. Okay, in the southern hemisphere, if you have clockwise movement, it's a low pressure. Okay, back on track. If we see clockwise movement, we know it's a low pressure. If we see anti-clockwise movement in the northern hemisphere, it's the opposite in the two hemispheres, then low pressure again, and that's what we're looking for. So let's start by looking down here. I don't really see any circular movement. Nope. There I see something. There we go. You see that there? There it's moving anti-clockwise. So that's a cyclone. Or cyclonic. It's not a hurricane or anything. I'm just saying it's cyclonic movement. So it's a low pressure system. Yay, we found one. Let's see if we can find more. Not much here. A little bit over there. You see over there? Slightly anti-clockwise. There you go. There's a little anti-clockwise. This is interesting. There's a little one. Well, slightly anti-clockwise. So another low pressure system. Sure, that must be rough. I would love to see a tornado. That's still like one of the things on my bucket list. I know it's a natural disaster, but the geographer in me just wanted to see a tornado. Ooh, this is a nice, very clear anti-clockwise movement. So very strong low pressure system over here. I wouldn't be surprised if this is something of a tropical cyclone or maybe the early formations of a tropical cyclone. Maybe, maybe. Okay. I see we're finding everything in the northern hemisphere. I guess that makes sense. I mean, it's autumn there at the moment, so we shouldn't expect to find anything in the southern hemisphere. Okay, so we found two that could possibly be something. So we will go investigate in a minute. Great. So we found low pressure cells. The air is pulled into the low pressure cell. So you can see it is like spiraling around and around, and it's kind of sucked up into the atmosphere. And this moisture is where the hurricane or the tropical cyclone gets its energy from. So what it does is it picks up all of that warm, humid air, and as it brings it up, as it starts to rise, that humid air will cool. And when it cools, it condenses. And as it condenses, it releases this energy, this heat that drives the hurricane or the cyclone. So a hurricane or a tropical cyclone is fueled by condensation. So the more moisture it has, the more it can lift that warm moisture up and condense it, the more energy it will have. Okay, and then finally, Coriolis force. So Coriolis force is what keeps everything spinning. Oh, sorry, no. Everything in the atmosphere and the ocean. Okay, Coriolis force is a force that happens from the Earth's rotation. Um, sorry, can ignore that. From the Earth's rotation. So as the Earth rotates, everything gets deflected. If we look, I'm trying to find an example. Can't really. Okay, so you can see that everything is kind of being blown into the same direction over there. That is because of Coriolis force. So in the northern hemisphere, it will deflect to the right, and the southern hemisphere to the left. Okay, and that's why it goes round and round. We need Coriolis force for a tropical cyclone to occur. But because of some mathematical delights, technically we don't have Coriolis force on the equator. And what that means is that we don't have tropical cyclones on the equator. So I found a nice map. I hope it's in these slides. Is it in these slides? No. Let me go find it. Is it this one? Yes. Here it is. So this is a nice map that has tracked some of the tropical cyclones and the very powerful tropical storms. And you can see something of a pattern, right? It never crosses the equator. It never even starts on the equator. So even though that is where the warmest water would be, that is where you would have the most fuel for a hurricane or a tropical cyclone, you need Coriolis force. So you won't find a hurricane or a tropical cyclone forming on the equator because there's no Coriolis force. Okay, that is why we would always see them from about 5 degrees north of or north or south of the equator to about, I think it's 30 degrees. I didn't note it. No. Okay, and wind speeds, very strong wind. Wonderful. So was just a run through about how the humidity is what drives the hurricane. So when the moisture condenses, so when the water vapor condenses, it releases this latent heat. Bearing in mind, not all of my students are science students or physics students, so I try to have this in simple terms as possible. It releases this latent heat and it uses this latent heat as its energy source. Okay, extreme low pressures will pull the air in, and adiabatic heating. So that's basically just as it cools. No wait, sorry, as it cools, as it rises, the temperature will change. That was just that. Okay, is all of this making sense so far? Any questions, concerns, queries? Okay. So those are the conditions that we need for a tropical cyclone or a hurricane to form. Yeah, in this curriculum, it is covered. So this particular curriculum that I'm covering is IEB, and they do include tropical cyclones in it, which I think is really nice because it's a very interesting topic in my opinion. So it is nice that it's included. I do just wish that we did tornadoes as well because I find those very interesting. Okay, let's see if there's anything that we're missing from general characteristics. It's just a bit of noise. And I don't know if you guys have said hello, but there's Mapuche sitting in the background. Say hello. Yeah, he's just having a quick snooze whilst we study. Okay. Mm. Yes, no, you're right. Okay, general characteristics. Let's see, what are we missing? Um, Low pressure system, warm oceans, hurricanes, typhoons. Don't know how correct some of this is. Um, okay, very destructive. Of course, it is a natural disaster. Oh, and this was just how the naming system works. So hopefully you guys know that it's named alphabetically. So the first one of the season is named A, and then the second one, Beryl. We had Hurricane Beryl. Um, so there's Hurricane Beryl, and then it just continues down the list. Where are we now? Aren't we like quite far down? I think we're at Milton or something now. We've had Milton. I wonder where we are on the list now. So you can see how many hurricanes there's been. Bearing in mind that this is per basin, so like per like ocean area, and each area, each part of the ocean will have its own list. There has been, I think, one occasion. Geez, are we at Raphael already? Well, let's take a look. Let's go to Zoom Earth. Zoom Earth. This is a very nice site that you can track all the current hurricanes. Okay, so I just want to start over here so I can show you. Oh, that's interesting. But you can see it has a different naming system. So this one is both Y and M. Maybe it started in a different ocean, is now working through. Um, Here we go. Oh, look, this kind of matches what we were seeing. So I think we saw something here. Yes, there. There we saw that low pressure system, and we thought that it might be some type of a cyclone. And there it is. So it is a category one. Is this now or oh no no no. It's a depression now. Okay. So it's a low pressure system at the moment. Um yeah, we'll find it. We'll find it. Wait, there's Patty. So it's a low pressure system at the moment, and it hasn't quite escalated to a hurricane yet. Not that I'm seeing. No. But all of these areas have a hurricane warning at the moment. Okay, so here is Patty. Is that on the list? Yes, there. There's Patty. Okay, let's see if we can find Raphael. Where's Raphael? Oh, unless this one's supposed to become Raphael. Yeah, it doesn't seem like this one has a name yet, but this one would probably become Raphael then. Okay, but that's good. We actually found it. Yeah, that makes sense. Because it looks like it's escalating quite quickly. If that's where it is now, it's a tropical depression now, so it probably will turn into a hurricane in the next few hours. Oh, sorry. The dog wants to get out. Yeah, I'll open the door for you. Off you go. Bye bye. There you go. Okay. So now we more or less know where we are on the timeline. You let the dog out, really? Yes, I let the dog out. Guilty. He likes to sit in the same room wherever I'm working, so he tends to like follow me around. It's very sweet. Okay, areas where tropical cyclones form. We covered that. We covered that. We usually near the eastern side. No, I'm not going to. Okay, so we usually see tropical cyclones towards the eastern side. So that is where you have the warm ocean currents, and it would move from the equator to the coastline. So let's see if we can find the typical path. I don't think we'll be able to find the path, but it would usually form around here where it's very warm, and then it'll blow towards the coast like that, and then it will try to deflect away from the coastline. As soon as it hits land, it doesn't have that water source anymore. So it won't have its fuel anymore. It needs a constant supply of humid, warm air. And when it leaves the ocean, it doesn't have that fuel supply and it starts to die down. That is why we might see it deflecting. It's trying to avoid the land and avoid the friction, and it tries to stay over the ocean where it has a water supply. And this side, the eastern side, is where you have your warm ocean currents, so it keeps that energy level up. Okay, all of that is good. Great. Okay, where should we go to next? Associated weather, stages of development, the impacts and management. Anything appealing? Or should we pick at random? Okay, let's see what kind of weather we have. Although I don't think this will really be news. In a nutshell, it's bad weather. It's quite unpleasant. Wouldn't want to be there. Okay, so this is just a nice cross section of what a hurricane looks like, a tropical cyclone looks like. In the exams, I've noticed they often like to ask something like this, the side view of how a tropical cyclone is formed. So we have the low pressure cell over here. We have the moist air rising, and that's why it condenses and makes those clouds. Um, you have sections where the air is descending again, and that descending air actually blocks any clouds from forming, which means that you have these layers of clear sky and then cloud and clear sky and cloud. That's also why you have the eye in the middle. Okay, so typically the eye wall, so the tallest clouds right in the middle, that has the most severe weather conditions. Okay, so a tropical cyclone can be very big. That's explanatory. It always has an eye in the middle. So I've often seen exam papers where they ask you what stage of development is this tropical cyclone in, and you'll usually just look to see if there is an eye visible, like over there you can see the little green dot. And if you can see the eye, then you know it's in the mature stage, and you can actually state because there is a eye developed or there is a clear eye wall. And then the eye wall is formed by cumulonimbus clouds. Very, very tall clouds. Okay. As the cyclone approaches, temperature increases. Okay, it's very warm inside the actual cyclone, inside the hurricane. So as it gets closer, it gets warmer. Initially, things might seem calm, pressure might fall, but as it comes closer, wind speeds will build up, rain will build up, and it brings with it storm surge. We tend to underestimate how much damage is caused by storm surge. We usually think about just the wind and the rain and all of that, but that flooding from the ocean, I'll see if I can find a nice diagram. Storm surge. That actually looks really cool. Open that image. Yes, please. Oh, well, that's not gonna work. There we go. This is a nice diagram. Okay, so that's supposed to be the normal conditions. And then here is the storm surge. So you see these waves coming and flooding in, and it just destroys everything on that coastline. Where was I? There we go. Okay, as the eye is overhead, slight increase in temperature, and then the wind suddenly drops. So it becomes very quiet in the eye of the storm. This does have the lowest air pressure. You might see a few little clouds on the top, but generally it's quite calm and somewhat sunny. Um, don't go out when the eye is busy passing over. I know it's a general warning that they give, but don't go out whilst the eye is passing over. Don't think that it's suddenly finished because the rest of the hurricane still needs to follow. Okay, then as it moves past, you basically have the same conditions but going in the opposite direction. Oh my word, that's terrible. Okay, well, good luck. I hope everything is okay. So as it passes over, everything moves into the opposite direction, and then it kind of starts to calm down. Yeah, I hear you. I hear you. Sure. No, that is. That is insane. Mm. Although to be fair, there's been some weird stuff happening in the atmosphere this year. I mean, Hurricane Beryl was also quite an anomaly. That was the end of that one. Nice, yes, please do. Maybe we can do a video looking at tornadoes. Admittedly, I've learned nothing about them, so it'll be completely new for me. Okay, let's see if there's anything else that really jumps out that I should maybe include. Mm, okay, I do just want to make a mention of a few things in anticyclones. Oh no, man, don't share. Ow! No. Hello. Welcome to GeoCafé. I see it's your first time here. How you doing? Okay, so I just wanted to make mention of a few things with anticyclones. So we were looking at cyclones and what they are in the atmosphere, and an anticyclone is the opposite of that. I'm great. So I'm busy running through some revision stuff. I am a geography teacher, and a lot of my students are writing their final exam tomorrow. So I'm doing a last minute revision study session for them to hopefully prep them for their paper. Sorry, the dog is scratching at the door, so I'll let him in. Yeah, do you want to come inside? Do you want to come in? Do you want to come in? No. I'll let you decide. I'll leave the door open. Sorry, the dog was scratching at the door, but he's not sure if he wants to come in or not. He just wants the door to be open. No, I am South African. Yay, thank you for joining. Okay, so cyclonic, I know you've just joined, so a little bit of a recap of what cyclonic and anticyclonic is. So cyclonic is when air moves in a certain direction. So in the southern hemisphere, that's clockwise. In the northern hemisphere, that's anti-clockwise. And a cyclone or cyclonic condition is the accent. No, it's a very South African accent. So cyclonic is where you have a low pressure system, so air is rising off of the ground. And then anticyclonic is the opposite. So anticyclonic, it goes anti-clockwise in the southern hemisphere, clockwise in the northern, and the air is sinking and pushing onto the ground. Okay, all of that fairly clear so far? Hello, Loki. Hi. Come in. Come say hello. Come. Oh. So this is my puppy. Let me just, there we go. This is my doggy. He's just brought me his toy to show off. Say hello. Hello, doggy. Hello. Yes. And you want to go play. Okay. Off you go. There you go. He's very proud of his squeaky toy. He's running around like showing. He's like, look, I have a toy. Okay. Next page. There we go. So another thing to note with rising air and sinking air is that a lot of it also involves temperature. So where you have warm air rises, And because it's rising, it's being lifted off of the ground. So it is a low pressure system. Where air is cold, it's dense, it will sink. So it will be a high pressure system. Okay, I think the dog's out. Don't think he's going to come back. There we go. Okay, so some general characteristics of high pressure systems or anticyclones. Sinking air, it diverges as it gets to the ground, so it sinks down and pushes apart. So that's supposed to be the ground over there, so it's a high pressure. The wind moves away from it. And because we don't have any air rising, we won't have any cloud formation. So for clouds to form, we need air to rise, so it will cool. And what that means is that by anticyclones, we'll also see a lot of clear skies. Okay. In South Africa, we've got our two major high pressure cells there and there, or two anticyclones. They very much do influence our weather over here. So this can block off any rain that comes from a mid-latitude cyclone. So throughout the seasons, it will move. We have the South Atlantic anticyclone and the South Indian anticyclone. And when we have winter, all of these systems will move slightly more north. So these systems, which bring our rain, can also move north, and it brings the rain. We have winter rain, or here at least, there. Then in summer, all of these systems move slightly more south, and these move closer inland, or closer south, closer towards the coastline, and that high pressure system prevents any rainfall from forming. Because the air is sinking, it's keeping the skies clear. Okay, so we've got very dry, very sunny summers. Okay, that part I want to skip, and I just kind of want to go to here. So this is another thing that I've seen in exam papers. They like to ask, how can you tell what season it is? Some telltale signs of winter is this high pressure cell inland. So we call it the Kalahari high pressure over there. We see around the coastline, it's quite cold, and you should see clear skies. Okay. Hey, you're back again. How are you doing? Good morning. Sorry, it's been a while. So we should see a high pressure cell. Oh, and then another one is the mid-latitude cyclone over here that kind of moves in. So I've got a synoptic weather map. I'm sure I do. I think I need to download it for it to actually to be able to rotate it. Okay, let me try. Okay, so let's download, and then I'll see if I can rotate that quickly so that we can see it. Where's that? There we go. Come onto the screen. There we go. Close that. Close. Okay, never mind. There we go. Okay, so we know what to look for to see if it's winter. Now I want to point out the opposite to point out that it's summer. So we have a low pressure cell. So warm air rises, air is lifted off of the ground, so it's low pressure, it's under less pressure. Over here, you can see that the high pressure cells have kind of been pushed towards the south and pushed away from the coastline. And you can see this mid-latitude cyclone, or just the little cold front that's left of it, over there and over there, are also quite far south. So if we compare that to what we saw over here, where there's a high pressure, the high pressure is quite close to the coastline, and we have a mid-latitude that's kind of on track on the same more or less latitude as South Africa. That tells me that this is winter and the other one was summer. Okay, I hope that's making sense. Okay, I'm not going to bother going through that. Rainfall. Right. So sometimes they ask things about how the high pressure cell could block rain. So if we have, where's my diagram? Inland of South Africa is more elevated. So we have this plateau inland. And when you have a high pressure system, it pushes the air down onto the land. What that means is that wherever you might have moist air trying to blow inland, it meets this high pressure that blocks it. So the moist air needs to blow in and up over the mountains before it will get into the land, into the actual country. But with this high pressure, you can't, it won't blow, okay? It's blocked. Then in summer, wait, where's my other diagram? Where's my other diagram? Okay, fine. We will just have to draw one. Where's Fig Jam? Hello, oh, there it is. Okay, sorry, this does make this stream a little bit laggy, unfortunately. Okay. That's our side view. Okay, that's the ocean. I'm just going to use orange to mark off where the high pressure is. So here we have the high pressure, like that. Sorry, dog scratching at the door again. Can't make up his mind. Do you want in our house? Come. Yes, boy. Okay. I'll stay there. No, stay. Yes, boy. Okay, can you guys see him over there? He wanted to play with his toy, but he wanted to do it here so that we can all join. Okay, so we can see that the high pressure blocks any air that is trying to blow up from the ocean and bring moisture with it. Making sure I've got the right one over here. There, that's there, in winter. So it's cold, it's dense, the high pressure is pushing down. When it's summer, the air gets warm and warm air rises. So what that means is that this is actually lifted off of the ground. So the high pressure is still there, it's just higher up in the altitude. So it's higher up in the atmosphere, it doesn't really affect the surface much anymore. Oh, okay. So at surface level, it looks more like there's a low pressure on the ground because the air is rising. And what that means is that this air, bringing moisture and rain, can come inland. And please tell me we've got little like cloud stamps or something. Cloud? Yay. There we go. And that can form clouds with rain. Okay, I hope that's making sense. My terrible drawing is making sense. Skip that part, skip that part. And I think we can actually skip those. So I'm probably going to start winding down to end this. But before I do, I first want to check from you guys. Are there any topics that you are interested in? Maybe any questions that you have that I can try and maybe explain or cover? I really hope that my matrics do well tomorrow. They've been working really hard. So I've been teaching them since they were in grade 10, so or no, longer. Earlier even. So they've been working for many years on this and I really hope that they do well. Becky, you are so indecisive. I know how to read maps and interpret maps. So we use two different types of maps. We use the orthophoto maps and we use the topographical maps. But I don't know much about making them. I think their GIS might be more interesting. So you can think of this as a more modern day version of map making, but it's basically like your software version or yeah, your digital version of maps. So GIS is a more new modern approach to maps where you can apply different layers and all the different layers have different information and value. So like for example, I can change the views over here of what I'm seeing. If I'm seeing precipitation, is this going to load? Oh, no. Okay, fine. Okay, so if I'm seeing precipitation or wind or humidity, so I would change the layer of the view. Um, and then you have information that is placed over that, like these lines and these dots over here. That is then connected to, it's not really working nicely, but at each dot or each location, there is a connection of information over there. So in this case, we can see the date, the time, the temperature, pressure, and everything like that. So in terms of map making, I think GIS might be a more interesting field to look into. But the old school maps or the hard copy maps, so your topographic maps or your ortho photo, or yeah, those maps, I'm not sure. I don't have much information on how they're made. I just know how to download them for the exam papers. Hmm. Okay. Well, thank you very much for joining. I hope that you learned something new, maybe had a few questions answered, and I hope to see you guys again. Other than that, have a lovely day, a lovely evening, or a lovely morning, and I will see you guys again next time. Okay. Cheers. Bye.